Welcome back after the break. Hello, hello. Let me introduce and Piotrek, who is representing today's sponsor, Software Mind. By the way, I am coincidence. Piotr have quite a louder voice, so don't worry, or just join the first row. It's harder with the mic and the computer. So everyone, round of applause for Piotr. Piotr will share with us the multi-agent games with LLMs. Without further ado, sir, stage is yours.
Thank you very much. So I was asked to speak loud because it's late already and I don't want to go to sleep quickly. So give me like 5 minutes, okay? So agent gangs, I'm going to talk about systems that will coordinate multi-agents in the environment. So you don't know what the agent is. Katarzyna talked about it a lot. Now we'll extend this topic by coincidence, and we'll work with multi-agent environment. So here's the agent. It's nice, but we need to know how to coordinate multiple of them in order not to be overwhelmed by the agents, by the AI. You know, there can be multiple of them, and you can lose control even more, right? And yeah, and the joke is good. Great. So my name is Piotr, Peter in English. I work in Software Mind. By coincidence, is today's sponsors again. Work at the head of data and AI, and you can find me in some social media, anything links. But the agenda for today, I will introduce the multi-agent system idea. I will show the examples. We'll play with them. I will talk a little bit on theory, and then there will be demo, which will hopefully work, but we'll see. If you have any questions, feel free to ask, of course, at the end or during the session. Okay, so you already know the agent idea. I prepared the simple drawing just to remind you that we have an agent, which is this one. Oh, sorry, is this one. We have a user. We are a user. We give a prompt, right? And the agent, based on the LLM, can choose to use a tool, and we can plug in many different tools. If you use LangChain, which you love, of course, you have a bunch of tools in LangChain, from SQL databases, vector databases, of course. You can use Google search. I know you can execute Python code, custom REST API. You can connect to SharePoint. Some people do this, believe me. We can do any other stuff, or write anything else by custom. And this is the agent, basically. Simple. If you work with, for example, assistants, right? Someone asked the question. This is an agent, simplified because you don't have so much tools to use, but you have like a vector database, code interpreter, and functions. Okay. Who of you attended the AI Devs course, the famous AI Devs course? Raise your hand. So you probably know how to build the agent because it was in the course. So we're not going to talk much about this. There are other tools for building the agent. You can use the cloud. You can use Azure, of course. You can, or other clouds, but I'm not going to mention them here in this place. You can use the custom GPT. If you know the GPT, it's paid, unfortunately, but you can create a custom GPT. It's like the assistant API in Azure, but the GPT. You can use the Open AI Assistant. You can use the other tools like Prompt Trainer. Here we begin here are the no-code tools, 1 to 5. You can use the LangChain that we love, of course, which is code tool. You can use Llama Index, for example, alternative. You can use Hugging Face transformers, not very popular, but still working. So this is the agent, okay? And now we want to have a gang. So we want to have multiple agents that will collaborate together to perform a goal or a task, right? And here's a very simple example. You have a gang of 2 agents. You have a researcher, you have a writer, and basically writer is the agent whose goal is to research the web about certain topic, right? And the writer, based on this research, writes something, in this example, a blog post, for example. Okay, that's the idea, the very basic idea. Why you want to use the multiple agents? Why we don't want to have just one? Basically, AI is generally stupid, and it needs very specified tasks. So if you work with large language models, you probably know that if you give him like a large prompt, system prompt or the user prompt, whatever, it will work better if you just specialize him in just one task. I don't know, do some summarization, do something. If you give him like set of instructions, he might get lost a little bit. That's why I want to like specify our agents in a single, let's say, task, single scenario. Secondly, the model's context is limited, so it can appear that we may hit this limit, right? So that's why we want to split our calls to the API, to the LLM into smaller ones, okay? That's why we split our system into multiple agents. Each agent calls the LLM independently. Each agent can have different role in their system. And basically, divide and conquer is our rule that we IT people love. So that's why we want to divide our complex tasks into simpler ones, divide the agents, and assign this task into single agents. That is more or less the idea, okay? Let me give you some examples. Some of them will be from your world, some of them not. But this one, the first one is very simple, very similar to the previous one. So we have a researcher, we have a writer. This agent has a tool which is a web search, so it can use, for example, a Google API, not directly the Google, but there's an API for doing web search. And based on the web search, he can perform research for the topic. And the writer takes this research, writes something about it, and we have it. Easy. Something maybe more, let's say, sophisticated. So let's meet the hedgehog, the jeżyk in Polish. So it is this guy from the beginning of the slide. And what's the role of the jeżyk? So jeżyk basically is an agent, or maybe agent. It's a system, okay, that can create stories for kids. That's the idea. Okay, the stories for kids. Not only, it also teaches English in the meantime. So that's the idea of generation of story for kids with the jeżyk, who is the main hero. Okay, this one. So we have a story designer agent, against the agent, whose role is to design an outline, so kind of a plot, main characters that are in the story, the plot, the main action, what will be the challenge for jeżyk to overcome during the story. That's his role, okay? There's a writer who writes, in fact, the story based on this outline. So we have like a sequential invocation of the agent. We have a writer here. We have an English teacher that do some magic in order to make this story more, let's say, the story can teach your kids something. And we have a reviewer, sorry, it will be a reviewer, but basically an agent who reviews the text, right, based on some criteria. And if needed, he can tell the writer, okay, do it one more time because you did something wrong, made some mistakes, grammar, spelling mistakes, whatever. Okay? And that's the idea of the jeżyk. The system that connects four agents that works together to create a story for kids that we learn. Are there any parents, by the way, of kids? Kindergarten kids, like 2, 4, 7? Yeah, cool, great. So the jeżyk is almost alive. You can join here. It will be soon see the daylight, and you will be able to use the jeżyk. It's almost developed. Yeah, there's a whitelist right now. So that's the second example of, let's say, multi-agent approach. I did it and it really works. I'll show you the small demo afterwards, but it really creates the stories. It's funny. More sophisticated example right now. Okay, you have more agents, right? Why don't you add some more? So we have basically a software house here, right? You can take it and you can, make money from here, from this. You have a bunch of roles: CEO, CTO, CPO, some programmers, designers, testers, even stuff like this. Okay. So you have this, let's say, upper part of the image. We have like a more or less the general idea how we design the code, right? We have the design of our application. We have the coding phase, testing, and documentation at the end. Okay. And here is this upper part is split into more detailed diagram, right? We give him a task to, for example, write me, Facebook application. Not Facebook is not, maybe Tinder, maybe Tinder was already application. Okay, and these agents cooperate together in this waterfall manner, and all of them here, they design the, let's say, the application, design the schema of your, for example, classes, choose the language, then the CTO begins to write the code, the programmers write the code, with the designer, with the reviewer, with tester. The process can repeat between these agents, because these agents like talk face to face, this one. And at the end, you have a result. You have a code that should work, hopefully. Okay, this is the idea. I'll show it to you in a few seconds how it can work. I don't know if you've played with ChatDev. It's an application that basically implements this schema, more or less. Or you have a MetaGPT that, again, it's an application that implements something like this, and it's also a framework, so you can use it to build your own solution that will use multiple agents. Okay. Okay, example time. Let's see some code. You're not here from, hide my credentials. Sorry. Damn it. No. Whatever. I don't pay for this. Oof. Hey, it's a company, don't worry. It's a sponsor, you can use it. It was recorded. Let's go to the demo, okay? Sorry. Okay. So here I have a MetaGPT. Sorry, it's a little bit large, and let me tell you this. Yeah, MetaGPT directory, my virtual environment for this. I hope it is here. No, this. Okay, and the idea here is very simple. Basically, we need to have a prompt, and I create the prompt here, right? So you can like take a look very quickly. I of course took some example, adjusted to my needs. Develop a web-based Minesweeper game. I know the Minesweeper, finally from Windows XP or Windows 98, someone perhaps. Using the Vue.3.js framework and all we need free files, app.js, index, and styles, CSS, and all the instructions about how the game should be designed, more or less. And that's all, okay? If I copy all this guy, go here somewhere, and basically MetaGPT, if I put this here, okay, starts to basically doing the job. And again, it will take some time. I have it ready because it will take like a few minutes. It begins with creating the documentation and the design of your code. It will begin to create the class diagram from my JavaScript file, okay? And then after some time, it will develop the code itself. It begins with the HTML, then the style, probably. And at the end, we have the result. Okay, so we have a file. It's using GPT-4 right now, so it's a little bit slow. But basically, you can see that all these agents using this MetaGPT are creating these goals, right? They will then create the user stories for the application. So it's like a junior software developer or software house that works to achieve your goal. Yeah, and it basically creates something, right? If you create a directory somewhere here, probably this one, you can see already some docs. I don't know if it's something there, probably not yet. It needs some time. But I ran it like yesterday for you to be ready with it. And we have this in this view Minesweeper directory, which is this one. Which is this one. We have basically all the resources. So we have the, where's the code? Not here. Where is my code? We should have a code somewhere here. Yeah, you can see how it's working.
How did you define the theme?
The MetaGPT already is defined. So this diagram that was here is this is basically. So you have a theme already defined. You can customize it if you want, but this is like you need to choose, right? I use GPT-4. You can, of course. I tried with GPT 3.5, and it was also okay.
I used a very similar tool a while ago, Pilot, and but I didn't. It was an early alpha, and it didn't get any results on GPT 2.5, and on 4 it got stuck at some point.
Okay. Let's do this because I prepared it. It should be here. Okay, yeah. So let's not refresh. Maybe it will work. So this is the something that was generated yesterday, right? It was a view Minesweeper. I didn't, it was ready. I didn't change the code. I didn't, correct the bugs. It was just as it. I was able to play like a Minesweeper, right? Okay. Where's the bomb? Yeah, there's a bomb, right? It is simple, but works. So it generates like, it took like a couple of minutes, around 8 minutes to develop all this system. Looks cool. Another tool that you can play with around from MetaGPT is ChatDev, and it's basically kind of simulation with the nice UI game, and each character in this world is like separate AI agent, right? You can customize this agent like here to, you can customize it with its own like tendency, what is his background, story, what is his goal, and so on. It has its own like language, and using this fancy game, you can just walk here and interact with the agents, basically. Okay, and what is nice, the agents are also collaborating with themselves. Okay, so it's not only the player with me, but also with other agents. Here is the simulation, but also ChatDev is also a tool. But here's the like a simulation for just for fun. Yes. It's like a sample implementation, basically. Right.
If I want to create two NPCs that just swear at each other, I can.
You can. Not right now because it's recording, from what I know, but later we can try. Okay, they are still developing, so you saw the results, so it should work good. You should already see, for example, some documentation that is beginning to appear, right? Like some requirements, project name, project goals, user stories generated by the agent, stuff like this. Okay. Yeah.
We can call this entity, and I understand that agents can call this entity, but as you said, we didn't change anything in the code, and the entity tends to be developed.
Yep.
And so on. So how the agents work? So how the agents perform on the
enchanting the existing code and project, not just creating the prototype, because to be honest, those prototypes for human are quite easy and we all know these games already, so it's it's nothing new, to be honest.
Yeah, that's right. That's right. It's a good question and a more tricky part. Basically, the MetaGPT itself claims that it can develop the existing code, right? I didn't try it extensively. I tried just one thing to add new feature to the game. It works, but I didn't use my custom repo from GitHub, and that's a good experiment idea. No. All this generation cost around $1. It's still cheaper than the developer. Really junior.
Piotr, there is a question as well from online. What happens if there is an issue with the code or a bug within the generated app itself? Is there a mechanism to fix it or to notify human being?
It depends on the, let's say, design of these agents. Here, they rather try to, let's say, solve the issue by themselves using this reviewer or tester with programmer communication. But you can also design a system, I will show it in a few minutes, where the user, let's say, the so-called human in the loop is active. So the user is a part of the, user is one of the agent, basically, in all the whole environment. Okay, for example, the last one is, again, the real world example. So imagine a RPG game, if someone you played a Dungeons and Dragons, perhaps. Yeah, there's a bunch of geeks that meet together. There's one game master who is a leader of the game, who designed the plot, the story, make up the character, and there are players. And basically, the idea is to replace the game master with the agent, which is this one. And the user plays with the game master, saying, for example, okay, I entered the dungeon, for example, right? This dungeon, let's assume the word, right? And the game master then takes the prompt, takes the message that the user wants to enter dungeon, and then he needs to collaborate with other agents. So it's a different schema. It's more like hierarchical. We have a master and, let's say, workers, other agents. So, for example, he calls the exploration agent. Exploration is responsible for designing the world, right? So he tells, okay, in the dungeon there is rooms, there is a monster, whatever, there's a treasure, stuff like this. Okay. He needs to be able to modify the world states, whatever it means. It's kind of an API under the hood. But basically, we need to save the game state, right? So we know that there's a dungeon, and inside the dungeon there is a treasure. We need to remember it for later. And if the user enters the dungeon and says, okay, I take out my torch, right, because it's dark, we need to, again, modify, for example, player state, because we need to check if there is a torch in the inventory. And if it is, we need to remove one torch because, yeah, it's obvious. Okay. So that's more or less the idea of this game. We developed the first MVP some time ago. Now we're doing the second phase using this multi-agent approach. We have a bunch of agents that work together. It's still in development, but I hope it will in some time see the world and we will be able to play it, basically. So another idea, different, let's say, structure of the agents. Okay. So what are the structures for multi-agent systems? We can have equivalent agents that collaborate together. We can have a leader and the followers, right? Which is, for example, this one, right? And we have also kind of network structure when we have leader and groups or single agents that communicate together. That are the most that you can use. The tricky part is the memory management. We have a short-term memory. It's basically a context that goes to LLM. So each agent can have its own short-term memory. It usually does, depends on the framework. We have the long-term memory, which is usually the conversation history. So the agents want to know what was the history, and we need to store it somehow permanently. Usually, the short-term memory is usually like just for a single conversation, and then it disappears. We can have external data using the rack for rack purposes. In the multi-agent environment, we also have episodic memory. So it's basically information about agents' interactions. So which agents interact with which, and what was the result of the interaction, what was the outcome. And we also have a consensus memory, which is a kind of shared information that we share between agents. So kind of shared knowledge for them. But it's not easy to let's say, manage the memory efficiently in this environment. We want to give good, let's say, piece of information to each agent. So it won't be not too much, not too less, right? In order to LLM to have a perfect piece of information from our whole ecosystem. And in terms of agent communication, we can have layered communication. So we have like a prompt or query, and the agents communicate like from the left to right. It was the Hierarchical case, right? Very simple, but here it's called the Dylan. We have a decentralized communication, so like peer-to-peer, so everyone with everybody. And we can have centralized with the master and the front. And the idea that was introduced by this MetaGPT, the message pool. So the agent pool creates a message to kind of, let's say, queue, and the agents can subscribe to the messages and read the messages that they need. So kind of, queue-based communication. Okay, we have frameworks, of course, for multi-agent systems. So if you want, I'll show you a few of them in a few seconds. You have a Crew AI, which is simple and nice to begin with. We have Autogen, which is also more sophisticated, but also quite nice. We have a LangGraph. We love it. It's from LangChain. It's more sophisticated, a little bit tricky, but doable. We have MetaGPT that I showed, and Camel AI. I didn't use it. Yeah, the one time. Let's see, by the way, how is doing he's still developing the code. So okay, let's leave him for this. Let's begin with Crew AI because I guess it's the simple one, the simplest. I already installed the dependencies from Python, some configuration. Let's leave it. It's not very important. Here we implement this researcher and let's say writer concept. Okay, very simple. We have a tool that do a website research. I give him just the arbitrary website from Microsoft Azure updates. Very simple. And we do the embedding here. I'll show in a few seconds. We have another tool which also scrubs the Azure Weekly website, again with Azure news and updates about Azure services. And you have two agents, which are here. You have the researcher agent. We defined him a role, his goal, the large language model, the memory, the variables he will print the output, the backstory is kind of, let's say, more system message, and the tools that he wants to use. So these two tools we give him, and that's all. And we have a newsletter writer. So yeah, here's a system that writes newsletter for you automatically. Again, role, goal, backstory, large language model, and so on. Let's execute this guy. And we have a task. We have two tasks here. Deprecated, don't worry. One task that we want to research the latest trends about Azure, right? And the second task that we want to write an engaging newsletter about Azure Cloud trends based on the research, okay? So two tasks, two agents, very simple scenario. We define the crew, because here is the Crew AI. That's how it works. We execute it. And hopefully, yeah, you have error. First hits one. Yeah. And we are doing something. I mean, the agents are doing something. They are collaborating together. They're using this chain of thought here. And so the agent thinks what he should do. He will search a specific website. He has a context from Azure website about the Azure updates, something about right here. Yeah, he gathers some recent updates from Azure. Oh, sorry for this. Okay, he gathered some more probably. Azure Weekly Newsletter, whatever. And in a few seconds, I hope he will generate the newsletter. Yeah, so if you want to know, you can automate this process, and you can have like a ready tool to generate you the content for your newsletter, for your blog post, for your Instagram, whatever. Jerzy will be in a few seconds, don't worry. Jerzy is still here. Is it alive? It is alive. Oh yeah, we have something new. We have final answer, right? So here we have a newsletter content, right, about the web application firewall, whatever, some Cosmos DB, stuff like this, okay? Right, you copy it, paste it, and send it to your subscribers, basically, more or less. Okay, the Jerzyk. So here we have an autogen from Microsoft. Yeah, so yeah, here we just the config. Here we have 3 agents. The designer agent who designed the story for kids, uses simple language and returns the story outline, right? Here you have a writer, he writes the story, and the critic who checks the story if it's okay and it's not okay. And here we have also a user proxy agent, which is this one, which is really cool, because this one basically is like a human in the loop implementation. So he will ask you if the story is okay, right? If you accept the story or not. Yeah, it's very simple. It's not the whole Jerzyk. It's just the the extract of the Jerzyk, the main. I mean the example from the Jerzyk. Jerzyk is more sophisticated because he adds this language capabilities to teach English to the kids. But let's stick to this. And here we create a group chat. We have a designer. These are these agents here, and that's all. So very simple example. And we want to generate a story for kids about the Jerzyk. Is this one. It's pretty fast. Maybe it's with GPT-3 pool, by the way. Okay. Autogen is nice because it shows you the communication. So here the admin to chat manager, because we have a chat manager always or almost always in Autogen. Then the chat manager to designer. Designer design the story about the Harry, a curious hedgehog, and some other let's say characters in our story, and then we have a story designed here. Okay, right. And at the end, he asks, here is the review of the story. It's beautifully crafted. It's nice. Here we can have a human feedback. So here we can type him if you want to change something. I can type, okay, I know, add rabbit, right? So this is my feedback from me, and he will add the rabbit. He will have a rabbit, which is nice. And then he'll create a story again. Yeah, so for a simple example, stories here. Let's check this once. Yeah, they finished the code implementation, so it took like a couple of minutes, as you can see. How's the time? Okay. The last one is LangGraph. It's more a little bit more, I think, difficult to enter because the CrewAI is really fast. You can just begin working with it. Autogen has more, let's say, features inside, but this example is simple. LangGraph is more interesting because it basically adds some more abstraction. So here we have the agent state, which is very nice object because here we can define what should be like a state for the agents that they're working together, right? So here you have a chat history, for example, right? You have agent outcome from the agent, okay? So you can control what's in the memory, and this is really cool. In the Autogen and the CrewAI, we cannot really do this. It's not so easy, but here we just explicitly define what should be in the memory of our agents, which is nice. Okay. Here some more, let's say, helper functions. Here we run the agent, we execute the tool. We have one tool here from LangChain, of course, and it's Tavily. So Tavily is like an API for doing the web search, basically. Okay, so kind of Google, but more different, but kind of. Okay, and at the end, when we have here, we defined a graph. So in the LangGraph, as the name states, we have a graph. Here we have two nodes. We have the agent node, which is our agent. We have the action, so it's node that executes a code, a tool in this scenario. Okay, we set this entry point. So when we begin our work, basically, and we define the edge. Here we have like one edge, basically, from agent to the action, right? So from this node to this node, here are the node names. And this action is, this edge is conditional. It means we don't always go here. We go here even only if the should continue function will return to true. Okay, or return continue, in fact. And the should continue action defined the result based on the agent outcome. So the agent says you should continue, then we will continue. If not, we will not. Okay. And that's the basically idea of the LangGraph. I try to do this very simple. If we add more nodes, more edges, it can get complicated, basically, the code, right? But here's the basic example. And if you ask him what is the difference between current weather in Warsaw and in Paris, for example, right, we'll get something, hopefully. Right, so here the agent used the tool, the Tavily tool, to scrap the weather conditions in Warsaw and in Paris. And somewhere here at the end, he should return, yeah, that here's the result, more or less, right?
Question?
Yep.
Maybe it's too short, but
Let me turn on the mic.
Okay.
No.
Like, can we connect agent to agent, or like
Yes, of
make
course.
agents cooperate with themselves?
Yes, here, of course. Here is a very simple example, but of course you can like add another node, right? Right here. Bank, we can have like run agent, whatever, too. This will be ng2. Then we basically add the edge somewhere here, and we connect these two nodes by the edge. Okay, so using LangGraph, we can make very sophisticated graphs that connects different agents, actions, and it works together, basically. And by the way, in terms of these our examples, right? So the Jerzy was implemented using AutoGen, as I said you, but this last the RPG game was more tricky to implement. That's why we use the LangGraph, because it gives you more flexibility, for example, in terms of memory management and in terms of context that is given to the certain agents. Okay, that's the idea. Okay, pizza time. So I think I'm almost finished. Okay, so that's all. One advertisement at the end. If you're interested in building agents and gangs with LangChain, yeah, yeah, cool. Thank you. I came up with an idea to create kind of workshops for everyone, for community, about LangChain, about building agents with Python, without theory, just a practice. LangChain with Python. For meetings recorded, was for free, online. Yeah, so you can just. I'm going to, let's say, do this workshop with you. It will be like practical sessions that you will work with the code. I will be just, the, guide, I would say. They will be in May. They will be in May. You have the dates here. If you go here, you can check it. And it's basically for let's say evenings with LangChain. You can attend for one, you can attend for everything. The agenda is more or less building the simple agents, and at the end we're going to build this, let's say, multi-agent something. Okay, using the OpenAI. Yeah, questions? Good question.
Just use the agent to live translate.
My idea was to make it in Polish, but after this question, I will think it through.
Any questions to Piotr? There was a hand up in the air.
Just a simple one. Can we try launching the second version of the game, or is it doesn't work from the first try?
Which we
The
are?
one it generated.
You mean this one?
Yeah, the new one.
The new
New
one?
Minesweeper.
Yeah, I hope
We
we
don't
can.
trust you. We want to see the results.
That's cool. I love it. Okay, view Minesweeper. Where's the code? Here is the new one. Yeah, we have app.js, index HTML, and style CSS. Okay, let's run it. Let's run it. You can see that looks like JS code, more or less. I'm confused with this. Okay, let's just, because not to make sure, let's copy path to this guy. Let's use.
And maybe I will ask in the meantime, in Crew AI, we specified LLM variable for each agent.
Yep.
Can we use multiple of them in separate agents and then use the third one to collect?
Yeah, we can use different LLMs for each agent.
Okay, yeah, that's cool.
Always.
Thanks.
Let's see. Oh, let's see. Restart. Really? Have an error.
The last one was just a slideshow.
Or something.
Yeah, let's take it offline.
We will.
Let's make agents to debug it.
Yeah, give me
till
like,
the end.
3 minutes. Yeah, more questions. Not really yet. I mean, it's still a very new concept, so it's hard to say that I won't say I have like 2 years experience with this. But one thing that, for example, appeared during our work, that this RPG game was very difficult to implement using, for example, AutoGen or Crew AI, because we needed to like give very strict context to each of the agents. That's why we chose LangGraph there. So LangGraph is like more, let's say, sophisticated, difficulter to enter, but gives you more possibilities.
Do you have any approach to test the multi-agent app? Because it seems really complicated stuff with a lot of black boxes.
Yeah, that's right. It's a little bit the same as testing, all generative AI applications. It's always random somehow, right? So you cannot really like do a hard-coded unit test very often, right? What we do is like we have like a test cases. We have like a set of, for example, prompts, right, and example outputs, and based on this we can evaluate based on larger data set what are the results, right?
Okay.
Even in Azure, you have a tool that is also already doing this. You have the Azure AI evaluation for the models, and they do it automatically in some way.
Sorry, but, great presentation. Thank you for showing us this. I was wondering, because it all creates software, right? It's software that actually creates software, and it's amazing to see those little agents that create all this. I was wondering, because usually you can tweak in those tools, what kind of agents are there? There's CTO, CEO, and everything. Do you have any control over the very code structure that is the output? Because I've seen that you basically, this is like an intermediate step in which you define agents who create the software, although there are like well-established like patterns or scaffolds for example, Vue projects or other projects. Is there a trial and error process to this, or rather there is a way to control or at least in broad strokes.
Using this, I mean, if you could go to MetaGPT, I encourage you to do this. Basically, MetaGPT in this way that I run it, right? Just very simple way. You just have a ready structure of your agents with the roles and prompts and stuff like this, okay? But the MetaGPT itself allows you, it's also a framework. It allows you to build all of this from scratch. So you can design every agent by yourself as you wish, basically, right? And you can structure him, give him the proper prompts, some examples, perhaps, as you wish, okay? Go to MetaGPT site and explore. It's quite cool. Yeah. Autogen has an agent who can run the code, and it can be in Docker because it's safer, right? And
I'm working in JVM normally, so you are not going to run Java on this because it's quite heavy to just do it iteratively like that. But so I think the currently used in this category of tools, the popular tools are of course Python to execute backend code or just code, and for front end it's
yep.
But the heavier the compiled languages, it's
it gets difficult. Right?
I think we are pretty close because if you can run a build script and then you can run stuff in Docker. We are there, but the technological capabilities are there, but this is not the most efficient way to do it. So tools are not being built for this yet. If
I know correctly, the guy, Gregory, who talked about TinderGPT, is also developing like a junior developer in Autogen. You can ask him what are the results.
Sorry to break into the story. It's a hot topic. We as well have another hot topic soon. So let it not become cold. I will cut questions now. Piotr is not gone. He will be here in the lobby. Ask him questions. Get in contact. Piotr, thanks a lot for your great presentation on agents. Let's have a round of applause.